Alright, we're going to graph a sine function, and this sine function involves an amplitude change, a period change, a vertical shift, and a phase shift. So it will get us through all of those checkpoints so we can see what it looks like and what process we would use to graph it when you have all of those combined. So first of all, let's take a look at our different parts. So the amplitude. So remember, amplitude, you look for the number that is multiplied by sine. In this case, there's not a number there, so our amplitude would just be 1. Okay, even though it's negative, remember amplitude is always positive because it represents a distance. Okay, so you take the absolute value of the number that's in front of sine. The absolute value of -1 is 1. The period. For the period, remember that sine has a regular period of 2 pi to go through one full cycle. So to find the period, we take 2 pi and divide by any number that's multiplied by our x here. In this case, it's multiplied by 3. So our period is going to be 2 pi over 3. Vertical translation, that's how far it's shifted up or down. Vertical translation is a number that's added or subtracted from the entire sine value. So notice we have a plus pi added here, but it's inside parentheses, so that means it's part of our sine function. Okay, the translation is located right here. It's a positive 2, so our vertical translation would be positive 2 or up 2. And finally, the phase shift. So the phase shift occurs inside of the sine function. This is our changes on our x, which means it shifts the graph to the left or to the right. To find the phase shift, you take the number that does not have the x multiplied by it. So in this case, we have our plus pi. And you write the opposite sign, so that's negative pi. You then divide that by the number that is multiplied by our x, that same number we used to find the amplitude. So we get negative pi divided by 3, which is negative pi over 3. So we have all of our parts and pieces. We know we have an amplitude of 1, a period of 2 pi over 3, a vertical translation of 2, and a phase shift of negative pi over 3. One other thing you want to take note of is this is negative sign, so we know that it will be reflected over the x-axis or flipped upside down. So that's one thing you want to keep in mind, because a lot of times as we go to draw our graph, we overlook that even though we knew it was there, and it causes us to get our graph wrong. So let's start graphing. Alright, so what do we need to draw a sine graph? We're only going to graph one period of this sine function, so we need to know where that period would start and where it would end. Now normally a sine function, one period, you can start at 0, 0, and then it will go up, down, and back up and start over again. Now it comes at 2 pi. So normally it has a period of 2 pi. And as we're graphing, the things that are important to help us graph one period are the starting point, the ending point, the middle, because that's where it crosses back through the center of the wave, and then the quarter, 1/4 of the way, so halfway between the start and the middle is where it hits its peak, and halfway between the middle and the ending point is where it hits its low point. So we kind of want to know where these items are so that we can label our x-axis to reflect that. Well, the first thing we notice is we have a phase shift of negative pi over 3. So our sine graph, instead of this one period starting at 0, it will start at negative pi over 3. Okay? And then in order to shift everything to the left one and have the correct period, the next thing that we want to do is just kind of map out where the start, the middle, and these quarter places will be. So we know we start at negative pi over 3, right? Okay. We want to have a period of 2 pi over 3. So to figure out where our ending point is for this one period of the function, we take our starting point of negative pi over 3 and add to that the length of the period, which is 2 pi over 3. Now if I add those, negative pi plus 2 pi gives me positive 1 pi over 3. So this is our ending point. So we know that one period of this function will start at negative pi over 3 and end at pi over 3. The next thing we want to know is where is our middle? Okay, where's the middle value going to be? And we can find the middle by averaging. So we take our starting point and our ending point and we add those and divide by 2. Well, negative pi over 3 plus pi over 3 is 0, and you're probably sitting there watching this going, duh, the middle of pi over 3 and negative pi over 3 is going to be 0. But here's the process. We then divide that by 2 and we get 0. Okay, so the middle of our wave, where it crosses back through its center, will be at 0. So far we know it starts at negative pi over 3, ends at pi over 3, and right in the middle is 0. We also want to know those quarter spots, so halfway between negative pi over 3 and 0. Let's find that. And again, you do the same thing. You add where you're starting and where you're ending, okay, and divide by 2. We want halfway between this. That gives me negative pi over 3 divided by 2, which is negative pi over 6. So I know that quarter will be negative pi over 6. I also want to know what will be halfway between 0 and pi over 3, and we're going to get a similar result if we add our start and end value that we're working with and divide by 2. That gives me positive pi over 3 divided by 2, which is positive pi over 6. So this actually worked out quite nicely. Okay, so our function will start at negative pi over 3. It will peak, or actually this is flipped upside down, so it'll hit its bottom at 0. We want to have our pi over 6, which is halfway between 0 and pi over 3. So here is negative pi over 6 on our x-axis. We also need positive pi over 6. Make sure those are about the same distance from 0. We don't want our graph to be odd shaped. And then pi over 3 would be one more mark away. So we have our starting and our ending and each of our important places. Next, now let's use amplitude and transition. So the translation is up to. So we know the center of our wave, instead of being on the x-axis at 0, will be up 1, 2 units from that. So now the center of our wave is about here. And if I were doing this with paper and pencil, after I finish the graph, I would go ahead and erase that dotted line. The amplitude is 1, so we know the low part of the wave will be 1 below that at 1, and the top of the wave will be 1 above that at 3. And then the other thing that we know is that it was multiplied by a negative. The sign was negative, so this is going to be flipped upside down. So instead of starting at its starting point and going upward, it's going to go down to its quarter point instead. So let's start. We're supposed to start at negative pi over 3. Okay, a quarter of the way through, it should hit that low point, because again, it's upside down. So it should hit the bottom here of its amplitude. And then halfway through, it should come back to center. And then another quarter of the way through, it should hit its peak. And then we will come back to center at the end. So this is what one period of this sine function would look like. Of course it will repeat, but they just wanted one period, and so that's what we would have.